Okay. Hi everyone. Uh, I'm going to present about influence of AI and machine learning in healthcare sector today. I'm Janith Prabhanuka. Uh, I'm going to cover this content in this section. Introduction to artificial intelligence, machine learning, and data science, which are the fundamentals for artificial intelligence-based systems in healthcare. Then applications in healthcare sector, case studies, and challenges and considerations in healthcare section and Q&A. So if we are considering about artificial intelligence, what is that? Do you have any idea? Okay. According to my point of view, science and engineering of making intelligent machines called artificial intelligence. This is actually not Krutima Buddhi in Sinhala. Actually, that's a wrong explanation about artificial intelligence because directly converted into Sinhala. So that should be බුද්ධිමය යාන්ත්‍ර විද්‍යාව. බුද්ධිමය යන්ත්‍ර නිපදවීමේ විද්‍යාව වගේ අයිඩියා එකක් තමයි එන්න ඕනේ. Right? Uh, okay. I have gave a simple explanation. Development of computer systems or software that can perform tasks that typically require human intelligence. Okay. There are features for artificial intelligence systems such as learning, reasoning, problem solving, perception, language understanding, and decision making. Oh, what's machine learning? Actually, machine learning is the technique used to train a machine using data, else allowing machines to learn by data. Then, machine learning is a subset of AI where computers are trained to learn and make decisions from data. It involves algorithms that improve their performance over time as they are exposed to more data. What's deep learning? Actually, you all are aware about these concepts. I am going through these sections because these are the basics for AI in the systems we have used in healthcare sector. Okay. Deep learning is a specific type of machine learning that uses artificial neural networks to learn from large amounts of data. Deep learning is particularly effective for tasks like image and speech recognition. Recognition tasks can be done using deep learning. That's not mean the only recognition and the speech recognition and image recognition can be done from deep learning. There are huge usages are there. When we are considering about the difference between machine learning and deep learning, you can see the machine learning is like that. If we give an input, uh, it extract the features and classify them. This is a classification algorithm. So classify and generate the output. In deep learning, if we give input, the feature extraction and classification done in same platform. This is a deep neural network, right? Then generate the output. This is the main difference between machine learning and deep learning. Okay, these are the neural networks. You can see this is first input layer. This is hidden layer, and this is output layer. We can make neural networks in multi layers according to our need and our objective. This hidden layer can be 1, 2, 3. So many hidden layers there. It's fine according to our requirement. Okay. A type of mathematical model inspired by the structure and functioning of the human brain called a neural network. That's similar to our human brain structure. Okay. There are interconnected nodes are there. You can see these all are interconnected. The nodes called neuron, as same as our human brain. Then information is passed through these layers, which with each neuron processing and passing on signals. Neural networks are building blocks of deep learning and are used in various AI applications. These are the neural networks are the building blocks of deep learning uh, application. Okay. Then we are considering about natural language processing. Natural language processing is a field of artificial intelligence that focus on enabling computers to understand, interpret, and generate human language. This is totally handling the languages and the words likewise. So NLP allows machine to process and analyze the text or speech in a way that makes it useful and meaningful. For example, chatbots, email filtering applications, language translation, sentiment analysis, smart assistants like Siri, Alexa, Google Assistant, then social media monitoring. Here, sentiment analysis is a special point. Sentiment analysis is a technique used in natural language processing to determine the emotional tone or attitude expressed in a piece of text. It involves analyzing text to classify the sentiment as positive, negative, or neutral, and can also identify more nuanced emotions such as happiness, anger, sadness, or surprise. Basically, this is so important to mental health analysis and the healthcare applications. Okay, but robotics. Robotics mean basically the creative machines or robot that can perform tasks or interact with the physical world in a way that mimics human capabilities. These are the examples: robot creation for DNA identification, medical robots are there helping to the patients, and robot helpers are there, sweepers, and mm, in addition to medical health robots, this is a shopping assistant, and home robots are there to help our daily activities. Okay. If we are considering about machine learning, there are three subcategories in machine learning: supervised, unsupervised, and reinforcement learning. Supervised learning is the algorithms are trained on a labeled dataset where each data point is associated with a target or outcome variable. Example, classification and regression, as we discussed earlier. Then, unsupervised learning that involves in training on unlabeled data where the algorithm learns patterns, structures, relationship within the data without explicit target variables. Clustering and dimensionality reduction is example for unsupervised learning. Especially reinforcement learning. An agent interact with an environment and taking actions, and it receives feedback and he is learning from the feedbacks. That's basically called reinforcement learning. So if you are considering about machine learning algorithms, we can see so many algorithms. First, we can identify what is an algorithm: a set of instruction or a sequence of operations designed to perform a specific task or solve a particular problem called algorithm. Okay. Then we can identify there are several algorithms in machine learning: linear regression, logistic regression, decision trees, random forest, support vector machine, k nearest neighbors, k means clustering, likewise. Okay, as we discussed earlier, reinforcement learning is a specific type of machine learning that especially help for healthcare applications. Then uh, this is a type of machine learning paradigm that focus on training agents to make a sequence of decisions in an environment in order to maximize cumulative reward. Okay, reinforced learning is a type of machine learning. So this is a subset of machine learning. if we are considering about the key concept in reinforcement learning, there is an agent uh, who is learning the environment and he is taking feedbacks. Okay. If we are considering how reinforcement learning works, first initialization is there. The agent start with no knowledge about the environment and often start uh, with a random policy. Then interact with the environment. The agent takes an action based on its current policy. Then it taking feedbacks. The environment responds to the action by providing a new state and a reward. Then it updates. The agent updates its policy and value functions based on the feedback received. Then iteration. Steps 2 and 4. I have told you interaction and update repeated until agent's policy converts to the optimal policy or a predefined number of iterations. Okay. Then types of reinforcement learning can be identified: model free versus model based. They are on policies of policies. There are so many types, and some applications can be identified for the reinforcement learning. Uh, there is a gaming application named AlphaGo. Then robotics applications are there. Atlas, the most popular example for reinforcement learning and the robotics combination, developed by Boston Dynamics. Then autonomous vehicles and advertising and recommender system and personalizing treatment plans and managing resource efficiency in healthcare. Uh, there are so many applications. Okay, let's move. This is about data science. What is data science? Data science is a multidisciplinary field that involves extracting meaningful insights and knowledge from large and complex datasets. You can identify it combines elements of mathematics, statistics, computer programming, domain expertise, visualization techniques to uncover patterns, trends, and valuable information from the data. Okay, let's consider about the applications in healthcare sector. The first one is disease identification and diagnosis. AI algorithms, particularly those based on deep learning, can analyze medical images such as X-rays, MRI images, and CT scan images, and the other diagnostic data to identify abnormalities and potential diseases. For example, AI can detect tumors, fractures, or infections in medical imaging with high accuracy. These systems can assist radiologists by providing a second opinion, uh, reducing the likelihood of human error and speeding up the diagnostic process. AI algorithms can analyze medical images. So, if we are taking a scan report, uh, it easily can identify what's the problem and from is knowledge, previous knowledge. So that uh, we need to train it before. Cancers and tumors can be easily identified. Then predictive analytics for patient outcomes. We can predict from past health data of a person what's the next condition that he has to face. You can see in this image. This is an analysis report about the liver, kidney, and his bladder. And likewise, sorry, this is my bladder. It's called Amashe, and bladder likewise you can take. So machine learning models leverage patient data to predict disease progression and outcomes. This helps in identifying high-risk patient, allowing for proactive and personalized treatment plans. What means proactive? Proactive means identify the uh, next step can be defined simply. Identifying the next step can be happen before it happens. Okay. Then uh, we can take some examples for this in future in next slides. Uh, Actually, the AI-powered predictive analytics can forecast disease outbreaks, patient admissions, and the progression of chronic diseases such as CKD, chronic kidney disease, and CLCD, chronic liver cell disease. Likewise, by analyzing patterns in healthcare data, AI can identify high-risk patients and predict adverse events, enabling early intervention and preventive care. For example, predictive models can help manage patient population with chronic conditions like diabetes by predicting which patients are at risk of complications. So, the next one is drug discovery and development. In earlier, uh, people have tried many types of efforts to discover the drugs for uh, specific diseases. But with the modern technology, we can easily develop drugs uh, and discover drugs for specific diseases because easily can be analyzed the gene structure and the structure of the viruses, and there are so many facts now. So we can identify the basic structure and we can develop a treatment patterning this manner. AI accelerates the drug discovery process by analyzing large data sets to identify potential drug candidates. So machine learning algorithms can predict how different compounds will interact with targets in the human body and identify possible side effects and optimize drug formulations. So this reduces the time and cost associated with bringing new drugs to market. For instance, AI can help identify new uses of existing drugs, drug repurposing, and design new molecules with desired properties. Okay, then personalized medicine. This is the most important application I have highlighted in healthcare sector as an application. Okay, AI can help in creating personalized treatment plans by analyzing a patient's medical history, like genetics, lifestyle, and other factors. So, machine learning models can predict how a patient might respond to different treatments and suggest the most effective options uh, considering. So this approach is particularly used in oncology, where AI can help tailor uh, chemotherapy protocols to the genetic profile of an individual's cancer problems, improving treatment outcomes. Okay, then this is the simple definition I have given for you. Analyze genetic, clinical, and lifestyle data, and approach enhances treatment efficiency and minimizes adverse reactions. This is like a smart doctor, right? That's why I put this image here. So personalized medicine can be only uh, implemented if the virtual doctor can identify the actual situation of the individual patient. Okay, next one is robo-assisted surgery. This is old technology now. I have seen so many applications uh, as robo-assisted surgeries. Okay, if you are comfortable with that, I can show some examples on YouTube, but you can find it in YouTube easily. No need to take time for that. Then continued continued advancement in robotic surgical system with increased precision, dexterity, and miniaturization of robotic instruments. That called if we are using our hand to do the surgery, we have to cut the as an example. Uh, this is this person's belly, no? So if we are cutting from the knife, there is a lengthy cuttings there. But if we are able to use a robo hand and do the cutting smoothly for the only for the necessary point, the required point, that would be a great help to the patient because uh, it helps to reduce the pain and the possibility of having a wound likewise. So in addition to that, let's imagine if we are doing a bypass surgery, so uh, how we can interact with the small blood vessels. So I think the robot system can do it in efficient way and the most efficiently uh, in called in smooth way, right? Uh, Actually, the robotic surgery systems used AI to enhance the precision and control of surgical procedures. These systems can assist surgeons by providing real-time feedback and improving the accuracy of incision and minimizing tissue damage. As I told, then AI algorithms can analyze the sorry preoperative and interoperative data, optimize data to sorry optimize surgical techniques and outcomes. Robotic assisted surgeries are often less invasive, leading to shorter recovery times and reduced risk of complications. Okay, then we can move to the next slide. Administrative workflow automation, simply called intelligent automation. So, if we are looking to this image, we can see uh, in a section. This is a section in scanning, and hospital staff is working, and this is another section. I think this is a laboratory. There's another section likewise. So, if we are able to synchronize the data flow of the all sections using technology, that would be much advantageable to the system. AI can automate administrative and clinical workflows, improving efficiency and reducing costs in healthcare settings. For example, AI can automate the processing of insurance claims, patient registration, and scheduling in clinical settings. AI can help manage electronic health records and streamline the documentation and support clinical decision making. Automation frees up the healthcare professional to focus more on patient care and less on administrative tasks. That is the most valuable advantage of this application. Okay, fraud detection and security. There are so many frauds happen in healthcare sector. actually some hackers taking persons data, people data, and the financial fraud is happening. Considering prevent healthcare fraud by analyzing patterns in billing data and detecting abnormalities. And additionally, it uh, enhance the data security by identifying potential breaches and vulnerabilities. That is the type of security mechanism. Okay. Uh, Remote patient monitoring. This is a valuable advantage of this application. Among this application, use of AI, continuous data collection can be done uh, while monitoring patient. Actually, the system can be identified like this. Doctor is monitoring the patient remotely, and patient is there, and supporter is there for patient. Uh, and doctor can identify if abnormal condition occur to the patient, and it can uh, managed. Okay. Remote patient monitoring involves using technology to collect health data from patients in one location and electronically transmit it to healthcare providers for assessment and recommendations. That is simply happen in remote patient monitoring. Uh, AI enhances remote patient monitoring in several ways. Uh, One type, continuous data collection. If wearable devices and sensors collect continuous data on vital signs such as heart rate, blood pressure, blood glucose level, oxygen saturation, and more. Uh, Examples are there. So AI algorithm analyze the data in real time to detect anomalies and trends that might indicate uh, deterioration in the patient's health. Okay. Then, so predictive analytics also a type. Machine learning models predict potential health events based on the collected data, allowing for early intervention. For example, predicting heart failure acceleration based on changes in heart rate and weight. AI can identify patterns that suggest the onset of complications, enabling preemptive measures. Then patient engagement also there. AI-powered platforms provide patients with real-time feedback and personalized health recommendations, and alerts and notifications also there. So data integration also there. Uh, Likewise, so many advantages there. Okay, next, the most important part, mental health monitoring. This is my research area because I have told the most important part. Uh, it analyzed behavioral patterns and speech to detect signs of mental health issues. If we are considering about mental health issues uh, that can't be easily identified, so it's very hard to understand. Even a doctor or even a psychiatric aren't easily identified the disorder because human brain is so complex, uh, the most complex organ of the human body. So if it feels sick, that's also hard to understand. So while understanding the mental health disorders and the mental health problems, this plays a vital role. Actually, if we are able to implement a system to identify the mental illnesses and uh, support system to heal. That would be a great invention we are doing to the community and the world and human beings, right? Uh, if we are considering about mental health monitoring, uh, AI involves in tracking psychological well-being and identifying signs of medical health issues through various digital means. The sentiment analysis. I told you about sentiment analysis. AI analyzes the text and speech from patient interactions, such as uh, their social media posts, chat logs, and therapy sessions to detect signs of depression, anxiety, and other mental health conditions. Natural language processing algorithms identify emotional tones and change in communication patterns that might indicate mental health deterioration. If we are considering about behavioral monitoring, wearable devices and smartphone sensors track behavioral patterns such as sleep, physical activity, and social interactions. Changes in these patterns can signal mental health issues. For example, decreased physical activity and irregular sleep patterns might indicate the depression. So, digital uh, devices can identify them. Okay, if we are able to take teletherapy support, that might that that is much grateful. So, AI-driven virtual therapists and chatbots provide more immediate support and cognitive behavioral therapy called CBT techniques. Then these tools offer 24/7 accessibility, providing users with coping strategies and emotional support. I will talk about this in next slides because I have developed a mental health assistant tool. Uh, and also risk assessment can be done, personalized mental health intervention can be done, support for clinicians can be done using AI in this section. What are the benefits of this AI interventions of mental health monitoring? Okay. Enhanced accessibility are there. So remote patient monitoring and AI-powered mental health monitoring extend healthcare services to remote the undeserved areas, providing continuous support. And early detection is most important thing. And personalized care uh, is a very important factor in mental health monitoring. Uh, it reduces the healthcare cost by preventing complications and reducing hospital visits. Likewise, that is the AI systems help people much. Okay. Uh, I told about my research area. Actually, I'm interacting with brain-computer interfacing and neuroscience features to uh, identify these mental health disorders and the uh, disorders and the abnormalities, and I'm trying to give solutions for this. So, if we are using brain-computer interfacing, uh, we are able to generate search and if we are able to treat these matters, that would be a great invention for the human being. So I'm trying to invent a solution for it. So that's my ultimate goal of learning these aspects. Mm, okay. According to my knowledge, all the mental health disorders and everything happens the chemical imbalance of the chemical act as the media among the neurotransmitters, uh, which is the media for electrical surges connecting the neurotransmitters. Uh, And if we are able to use a solution for this changing and back to normal, back to normal state, that would be very beneficial to healing these issues. So I'm trying to change the electrical surges patterns, and if every disorder occurred from because of an specific reason. So if we are able to take it back to normal, that would be very beneficial to every human being, because we can't tell anyone who is suspecting from a mental health disorder, and anyone can affect from the mental health disorder. Like actually, we are in our daily life, we are facing so many problems. So everyone is in the risk of affecting a mental health disorder or any disease. So this would be much beneficial. So if we are looking about the mental health monitoring with a brain computer interfaces and treatment of mental disorders, according to my experience in these BCI platforms, uh, I am able to give you some information. So I am going to discuss about that. Uh, Actually, brain computer interfaces represent a cutting edge technology that allows direct communication between the brain and the external devices. Integrated BCIs with mental health monitoring can revolutionize the diagnosis, monitoring, and treatment of mental disorders by providing real time insights into brain activity and enabling novel therapeutic interventions. So, BCI enhanced mental health monitoring is uh, very beneficial. Okay? Real-time brain activity can be monitored. So, BCI can monitor electrical activity in the brain using EEG. Do you all know EEG? There are scan machines also there. Electroencephalography called EEG, or other neuroimaging techniques are there. So, real-time analysis of brain signals can identify patterns associated with mental health conditions such as depression, anxiety, and such type of mental health illnesses. So, early detection of mental health issues can be done by BCI. So, by continuously monitoring the brain activity, BCI can detect early signs of mental health issues before they manifest as behavioral symptoms. This enables proactive intervention and personalized treatment adjustment. So, uh, VCI enhanced mental health monitoring involves neurofeedback therapy. So, neurofeedback uses BCIs to provide real-time feedback to patient about their brain activity and its behaviors. So, patient can learn to regulate their brain activity through guided exercises, which can help alleviate symptoms of disorders like anxiety and depression. That would be beneficial. And cognitive and emotional state monitoring. BCI can assess cognitive load, stress levels, and emotional states by analyzing brainwave patterns. So, this information can be used to tailor mental health interventions and support, providing a more personalized approach to care. Okay, if we are considering about healing mental disorders using BCIs, so we can identify some important points. So, targeted brain stimulation. BCI can used in conjunction with non-invasive brain stimulation techniques such as sorry, transcranial magnetic stimulation (TMS) called, and uh, transcranial direct current stimulation, TDCS code. So we can monitor like the behavior pattern of brain from that techniques. So these techniques can modulate neutral activity in specific brain regions associated with mental disorders, providing uh, therapeutic effects for conditions like depression and schizophrenia. Okay. Then brain-computer interface therapies are there. BCI can facilitate direct brain-to-brain communication, potentially allowing for new forms of therapeutic interactions. Patients with severe mental disorders can receive real-time cognitive support and behavioral guidance through BCI medicated interventions. Okay. Then let's consider about rehabilitation and cognitive enhancement. BCI can aid in cognitive rehabilitation for patients recovering from neurological injuries or disorders. Techniques such as brain-computer interface training can enhance cognitive functions, improve emotional regulations, and support the recovery of patients with mental health issues. If we are considering about personalized medication management, this is a main important point for BCI. BCI interference of mental health monitoring. Uh, Earlier, I told you personalized medicine is the most important factor affecting the mental health monitoring. So and medication. So this will be helpful in personalized medicine as a this interact as a smart doctor by identify individuals historical data, clinical data, and everything. Okay. If we are considering personalized medication management, BCI can provide insight into how different medications affect brain activity, enabling personalized medication regimens. So this can help optimize treatment for conditions like bipolar disorder. I mentioned there bipolar affective disorder, where medication management is crucial for stability. Okay, integrating AI and BCI for comprehensive care. We can implement AI and BCI for comprehensive care of a patient. Combining AI with BCI technology can enhance mental health monitoring and treatment. So then AI algorithms can analyze BCI data to predict mental health episodes, suggest interventions, and adapt treatment plans dynamically based on real-time brain activity. Okay. Then what are the benefits we can get? Enhanced precision is there. So BCI provide precise measurements of brain activity leading to better diagnosis and more effective treatments. Immediate feedback. Real-time feedback helps patients self-regulate their mental state and improve their mental health outcomes. No? So innovative therapies. So BCI enable new therapeutic approaches that are not possible with traditional methods. So offering hope for treatment-resistant conditions. That's the most important valued advantage we can take. Okay, let's move. These are the case studies for the healthcare and the uh, sections. Actually, I have only demonstrated the two papers here. Okay, let's consider about the case studies involved in healthcare studies. So uh, there are two papers here. The first one is a research proposal made by me to identify and find solutions for neurological disorders. If you need, we can have a look. The other one is robust micro emotion detection paper. This is my final year project at university when I was studying for my BSc. Uh, so this is the paper integrating AI-based diagnostic for enhanced diagnosis and management of neurological disorders, uh, Alzheimer's, Parkinson, and dementia. So I have written this for applying for a PhD scholarship, and this was the research proposal. When we are going through this paper, actually this is focused to uh, identify that above mentioned diseases using the scanned images. Likewise, by the PET scanner, we can take the images of the brain and analyze the uh, reports according to the diagnosing criterias. This is the involvement of AI. If we are considering about this, uh, first image acquisition is there, taking images from the PET scanner, then processing the image and uh, convert it to analyzable format and uh, flowing through the deep neural network as I told before, and finally image interpretation, and it can show a decision. Uh, Finally, by evaluating the data given, the system can generate a decision. What is the disease is present or not? Likewise. So this is the main focus of that. I will share these documents with you. Uh, okay. The other one is robust micro emotion recognition. Actually, this is my final year project at my BSc. So this examine the facial expressions drawn in the human being. Uh, if if we are suspecting he has a any disease or any disorder, we can identify it easily. The purpose was identify micro emotions drawn on the face, which are tried to hide from the actual feeling that can be identified. Actually, we have developed this for identify suspective people, but this can be used in healthcare issues also. So, if we are analyzing a patient, we can determine it. Okay. Then let's consider about the special facts such as personalized medicine. Okay. Then let's move to the next section. Mm, personalized medicine. Okay, let's move to the next section, personalized medicine. I'm going to give some examples for personalized medicine. Actually, you can remember I have told before, uh, treatment plans based on individual patient data can be given by personalized medicine. So, genetic, clinical, and lifestyle data to tailor treatment plans based on individual patient characteristic. This approach enhances treatment efficiency and minimizes the adverse reaction. Okay, if you need, you can go through the example I have given. This is an example virtual health assistant named Medibot. I found this from the internet and it's asking about your current health problems and the chatting there. Uh, Actually, from the influence I gained from this, I have developed a virtual health assistant. Actually, virtual health assistant mean AI-powered chatbot and virtual assistant able to provide information, answer queries, and offer basic healthcare advice, improving patient engagement and accessibility to healthcare resources. So, considering about Sci Health version 1.0 developed by me, I will explain about that. Uh, and considering Sci Health 1.0, that's the expert system developed by me to analyze mental health disorders before meet a psychiatric or psychologist by understanding symptoms and evaluation given by the system, right? Then it can be identified these disorders in the current stage: alcohol dependency, OCD, obsessive compulsive disorder, depression, schizophrenia, and bipolar affective disorder. Okay, do you really need to try it? Okay, let's try it. This is the link for the cloud, but I will show you a demo. This is the system I told you. Uh, okay, I hope you all can see my screen. Uh, you can take more details from clicking this detail section. There's another presentations there. So considering this Psi Health, I can demonstrate what is happening here. If uh, we run this. Okay, let's go through the Psi Health. So I'm going to demonstrate about it. Then this is the expert system I have developed. I hope you all can see my screen. Uh, okay. Mm, if we run this, you can identify if you are suspecting you are suffering from any mental health disorder. You can identify it by identifying the symptoms, and system is able to identify your symptoms, and it generates a marking scheme, and according to your responses it generate you are in which stage, and what's the disease you are suffering from, and what are the recommendations and lifestyle changes, and uh, as the personalized medicine there are some coping strategies like us. So you can identify those. If we run this, first, you need to select a disorder from the list. If we select OCD, obsessive compulsive disorder, that means the process doing repetitively. So එකම දේ නැවත නැවත කරනවා වගේ දෙයක් තමයි එතනදි වෙන්නේ. අපි මේක go through කරොත් do you experience recurrent and persistent thoughts, urges, or images that are intrusive and unwanted? If we select yes, then asking another question, do you try to ignore or suppress these thoughts? or neutralize them with other thoughts or action. Yes. Then let's select yes and yes. Finally, it generate according to our uh, responses. You are in OCD first stage since showing the obsessive thoughts. So if we select no, considering the above four questions, it generate convergences. You are healthy. Likewise, let's take for alcohol dependency. First, he's asking a question to uh, go through. So when click OK, uh, it asks how often do you have a drink contains alcohol. So if we uh, select four or more a week, do you feel need to drink alcohol in the morning? That is a symptom of severe alcohol dependency. Yes. Then have you experienced tremors when you are stop drinking? Yes. Uh, do you feel anxious when you are not drinking? Yes. Yeah. Take, uh, yeah. Finally, it generates the result. You are in severe alcohol dependency stage. Please meet the doctor as soon as possible. You will be able to recover soon from proper treatment. These are the evaluations. So by this system, you can identify if you are suffering from any mental health disorder, if suffering, which stage you are, and then recommendations supposing and coping strategies also suggesting uh, doing by this expert system. In the expert system, there are so many options. According to my memory, there was an option if you are in a moderate level of any disease, you can select the options. There was a contact number of a national mental health institution uh, located at Mulleriya. Then 1926, as I remind, there is a suggestion call them and ask for recommendations, and they are helping for you. That would be more beneficial for you. So if you are really interested about uh, this expert system, I can give you more details by uh, clicking this detail section. You can take the information, uh, and I will include a link also. Then let's move to the section. Uh, Next section. Okay, we were here. Okay, next, we are able to take a hands-on experience on the heart disease prediction. Okay, there was a system uh, to analyze heart diseases and the possibility to occurring a heart disease by the analyzed data. So machine learning algorithms used at there, and they are mentioned here: logistic regression, scikit-learn, naive-bayes, support vector machine, k-nearest neighbors, decision tree, random forest, XGBoost, artificial neural network with one hidden layer. These are the machine learning algorithms. This is not a machine learning, that's a deep learning algorithm. So accuracy achieved 95% from random forest algorithm. So we are going to the uh, example. You are able to see the analysis report. Okay. If you are considering about the hands-on experience on heart disease prediction, you can access the project here. So I have loaded it before. This is the project. So going through this, here import the libraries and the analysis done. And this is analyzing data set. And then they have done some settings to take a result from this analysis. Uh, this is the exploratory data analysis stage, then processing data and EDA done, then analyzing data and visualization by bar plots. Uh, then finally, they are able to generate accuracy report. This is the model training. Uh, there are 300 epochs are there and model training is there. So if we are running this time, that may consume more time because I have run before it. So finally, the output final score stage, you can take the accuracies in this manner. Accuracy gain from logistic regression is 85.225 percent. From naive Bayes, the same, and support vector machine 81.97. K nearest neighbors 67.21%. Decision tree 81%. Random forest 95%. Uh, XGBoost 85%, and using a neural network 80%. So we can see the most accurate one is random forest for this data set. So this is the visualization of accuracies. That's all. Right. Okay, let's move to the next section. Challenges and considerations in healthcare. As every section, challenges also they are in healthcare sector also. Right. Then we are considering about ethical consideration. There are problems with transparency and fairness, and data bias, privacy bias, reliability and trust, ethical dilemma. Okay, ethical considerations. Uh, uh, the challenge is the transparency and the fairness of the data. So we don't know uh, the security mechanisms used, and if anyone interfered to the data collection procedure by hacking, there can be fake data is there. So patient privacy is the most important one. So importance of safeguarding patient info is yes, most valuable one. So if anyone steal the patient's private data, such as their name, age, ID number, likewise the most important data from a database, that would be a great severe damage to their system. And when we are looking at the patient side, that would be a very difficult problem. So data breaches can be there. Regulatory frameworks need to implement uh, to keep the patient privacy. So integrating with existing healthcare system is the other problem. So all we know, the existing system is not much updated with the technology. At least there are no patient record system also in digital manner in some hospitals. So we are facing challenges in integrations and a smooth collaboration with existing technologies. It's very harder to tally with the existing technologies, the existing healthcare system. That's the most challenging factor in healthcare while implementing AI. We need to balance innovation and practical implementation. And we have to plan this before implement the systems, AI systems to healthcare section. So we can identify these five uh, trends as emerging trends in AI/ML in healthcare. So if we consider about explainable AI, explainable AI refers to AI system designed to be transparent and understandable to human users. In healthcare, the importance of explainable AI lies in its ability to provide clear and interpretable insights into how AI models make decisions, enhancing trust and facilitating uh, clinical adoption. Okay, right. Uh, by enhancing trust and transparency, explainable AI helps clinicians understand the reasoning behind AI generated diagnosis and treatment recommendations. By making AI decisions uh, more transparent, healthcare providers are more likely to trust and adapt the technologies. So, regulatory compliance. So, explainable AI aids in meeting regulatory requirements by providing explanation that can be used to justify medical decisions and ensure accountability. This transparency is crucial for obtaining approval from regulatory bodies like FDA. There are so many regulating bodies, and FDA is the most popular one. So then, improved patient outcome can be taken by explainable AI. By understanding AI-driven insight, healthcare providers can make more informed decisions, leading to better patient outcome. So, patient are also more likely to accept and adhere to treatments when they understand the reasoning behind it. Right. When we are considering about AI-powered virtual health assistant, as we discussed earlier, AI-powered virtual health assistants such as chatbots and voice assistants provide patients with real-time support and information, improving accessibility and efficiency in healthcare. When we are considering about the features, 24/7 patient support can be given through the virtual health assistants. Virtual assistant offer round-the-clock support, answering patient queries, scheduling appointments, and providing medication reminders can be done. In this constant, availability helps reduce the burden on healthcare providers and enhances patient satisfaction also there. Symptom checking and triage can be done by the virtual health assistants. AI virtual health assistants can perform initial symptom assessment and triage and guiding patient to appropriate care resources based on their symptoms. This helps in reducing unnecessary hospital visits and optimizing the use of healthcare resources. Right. The next one is blockchain in healthcare. Blockchain technology offers a secure and decentralized way to manage healthcare data, enhancing privacy, security, and interoperability. So, considering data security and privacy, blockchain ensures secure and tamper-proof storage of patient data, protecting it from unauthorized access and breaches. So patient can control their data and grant access to healthcare providers as needed, maintaining privacy. Considering interoperability, blockchain enables seamless data sharing across different healthcare systems and providers, improving care coordination. So this sorry, interoperability ensures that healthcare providers can access to complete and up-to-date patient information. Considering transparent and immutable records, the immutable nature of blockchain records ensures that any changes to patient data and they are transparent and traceable, enhancing trust in the data's integrity. So transparency is crucial for clinical trials, insurance claims, and regulatory compliance. Considering about federated learning tools in healthcare, federated learning allows AI models to be trained across multiple decentralized devices or servers while keeping data localized, enhancing privacy and security. So, considering about data privacy, federated learning keeps patient data on local devices, ensuring that sensitive information is not shared or centralized. Then, this approach minimizes privacy risk and complies with regulation like GDPR and HIPAA. There are regulation bodies most popular known as. So when we are considering about collaborative model training in the federated learning tools, healthcare institution can collaboratively train AI models on diverse datasets without sharing patient data. So that is most important factor in collaborative model training. So this collaborative approach improves the general generalizability and accuracy of AI models across different populations and conditions. The next one, scalability and efficiency. So federated learning enables efficient and scalable AI model training, leveraging distributed computing resources. This scalability accelerates the development and deployment of AI solution in healthcare. So as a final one, we can consider the AI-driven mental health tool. I have explained those in previous sections also, so I will quickly go through. AI-driven mental health tools like I shown you the Medibot and Sci-Health can use machine learning and other AI technologies to monitor, assess, and treat mental health conditions, providing innovative solutions for mental health care. While considering the features of them, real-time monitoring and assessment can be done. So AI tools can monitor mental health by analyzing data from smartphones, wearable devices, and social media to detect signs of mental health issues. And the real-time monitoring enables early detection and timely intervention. So we can do personalized therapies with the mental health tools. AI-driven mental health platforms offer personalized therapy sessions, providing tailored recommendations and interventions based on individuals' needs. So I'm going to I'm going to develop a system as my next step like this, personalized medicine and personalized therapies focused on mental health. And let's see. Virtual therapists and chatbots deliver cognitive behavioral therapy, CBT called. So techniques and supports can be used. Then brain-computer interfaces also can be used in AI-driven mental health tools, as I discussed earlier. BCI enable direct communication between the brain and external devices, offering novel ways to monitor and treat mental health conditions. PCI can provide neurofeedback therapy and real-time brain activity monitoring and targeted brain stimulation for conditions like depression and anxiety. Then predictive analytics also can be done. AI models can predict mental health crisis by analyzing historical and real-time data, allowing for sorry, allowing for preemptive measures. These predictions help healthcare providers to intervene early and manage mental health conditions more effectively. Uh, these emerging trends in AIML in healthcare demonstrate the transformative potential of technology in improving patient care, enhancing operational efficiency, and enabling innovative treatment. Let's move to the next section. Uh, what I told through the session, you can see in one picture. This is the involvement of AI in healthcare can be demonstrated in one picture. Online consultation is there, pocket doctor, home doctor, medical wearable devices are there, medical technology, smart ambulances. These all are connected with IoT and so many systems, blockchain there. So, as we discussed, future trends in AI, ML in healthcare, telemedicine will be there, healthcare devices and health monitoring, mobile health. Uh, these also we have discussed. Okay, we have already discussed about these sections earlier. So this is a summary of future trends. Then, if you have any questions, please feel free to ask. Okay, seems like any questions, so we can wind up the session. Thank you.